In this video, we are going to talk about expanding binomials and completing squares. To refresh your memory, when you are expanding binomials, you have to find the product of two brackets with two terms each. Now, the process is very simple. You just multiply each term in the first binomial by each term in the second one, and then you collect the like terms and simplify. Let's do the first example. Let's say we have to expand and simplify x plus 1 times 3x minus 5. The way we do it is that we are going to follow the arrow, the first term of the first binomial multiplied by each term of the second one, so we get 3x squared minus 5x, and then 1 multiplied by 3x and 1 multiplied by negative 5, we get plus 3x and negative 5. Now, there is no like term to 3x squared, so we get 3x squared. Negative 5x and 3x gives us negative 2x, and then we are left with negative 5 too. So the final answer is 3x squared minus 2x minus 5. Let's say we have to do x plus 2 times x minus 2 times 2x minus 3. Again, we are going to multiply the first bracket by every term in the second bracket, and then we simplify the product, and then we multiply by the third bracket. So here we get x squared minus 2x plus 2x minus 4 times 2x minus 3. Now, x squared, there is no like term, but minus 2x plus 2x gives you 0, and then we get negative 4 times 2x minus 3. We do exactly the same thing. We are going to multiply every term by the terms inside the second bracket, so we get 2x cubed minus 3x squared minus 8x plus 12. And if you look at every term here, there is no like terms, so the final answer is 2x cubed minus 3x squared minus 8x plus 12. Remember that every quadratic can be written in three different forms. One is called standard form, which is in the form of y equal ax squared plus bx plus c, where a, b, c are real numbers and a cannot be equal to 0. The nice thing about standard form is by looking at the equation, we can see that the y-intercept is the constant. This is the y-intercept. The next type of quadratic equation is x-intercept or factor form. In this form, y is equal to a times x minus x1 times x minus x2, where a can be any number, a real number other than 0, and x1 and x2 are the roots or the zeros or the x-intercepts of quadratic equation. The third one is called the vertex form. In the vertex form, the equation is y is equal to a times x minus h squared plus k. Now, the nice thing about vertex form is that the vertex, the coordinate is h and k. Now, the vertex is either maximum or minimum depending on the value of a. If a is less than 0, meaning it's negative, then the parabola is going to open downward. So the vertex, which is here, is going to be the maximum. If a is greater than 0, meaning positive, then the parabola opens upward, then vertex, which is the minimum point here. Now, Depending on the value of a, just to recall what you learned in grade 10, if a is less than 0, then there is a reflection on the x-axis. And if a is greater than 0, then the parabola opens upward. So this is the case that a is greater than 0, and this is the case when a is less than 0. In the case of a greater than 0, the vertex is the minimum point, and in the case of a less than 0, the vertex is a maximum point. Now, depending on the value of absolute value of a, recall that the absolute value is represented with two vertical lines, and it represents the positive value of a number. Let's say the absolute value of -5. It is 5. This is a number without sign. The absolute value gives you a number without the sign. Absolute value of 7 is the same as 7. Now, if the absolute value of a is greater than 1, then the parabola is going to be stretched vertically. If the absolute value of a is between 1 and 0, then the parabola is compressed vertically. Values of h and k represent the translation of the parabola either horizontally or vertically. If k is greater than 0, then it means that the parabola is moved up vertically, and if k is less than 0, then the parabola is moved down. For h, if h is greater than 0, then the parabola is moved to the right horizontally. If h is less than 0, then the parabola is moved to the left horizontally. Now we are going to talk about completing squares. How we are going to change from standard form to vertex form. The way we do it, we use completing squares. In completing squares, we follow the following steps. First, we are going to group all the x terms. Then we are going to common factor the a value, if there is an a value exists. Then we are going to divide the coefficient of the x term, or the middle term, by 2. Then we are going to square it and add and subtract that number inside the brackets. And then remove the subtracted term from the brackets. It is multiplied by the a value. And then we factor and simplify. Let's see these steps through examples. The first example says convert to vertex form y equal x squared minus 6x plus 2. First of all, the a value is 1, so there is nothing to factor. So we are going to group the first two terms which have the x term. So this becomes x squared minus 6x close bracket plus 2. Then we are going to divide minus 6 by 2, we get minus 3, then square minus 3, we get 9. So we are going to add and subtract 9 from the inside of the bracket, so we get x squared minus 6x. First we add 9, then we subtract 9. Always add, then subtract, plus 2. Now we are going to look at these three terms. These three terms are the same as x minus 3 squared, because x minus 3 squared gives you x squared minus 6x minus plus 9, and then we have a minus 9 here plus 2. There is no coefficient here, so we just take the bracket out. We get x minus 3 squared minus 9 plus 2, which is going to be x minus 3 squared minus 7. Now, looking at this one, you can see that the a value is 1, h value is 3. Remember, the formula is x minus h. So h is 3 and k is negative 7. This is the completing squares. If it doesn't specify in the problem that you have to use completing squares and you want to convert standard form to vertex form, there is another method which is very fast, much faster than completing square. What you do is that the x-coordinate of the vertex is always equal to minus b over 2a. Now, if you look at this equation, minus b is minus 6, which is 6, divided by 2a. A is 1, so it becomes 2, so 6 divided by 2 gives you 3. This is the x-coordinate of the vertex, and you can see the x-coordinate of the vertex is 3 here too. To find the y-coordinate, we plug v sub x equal to 3 in the equation, we get 3 squared minus 6 times 3 plus 2, which is 9 minus 18 plus 2, which is negative 7. And this is negative 7 here too, the same thing. So if the completing squares is not mentioned, you're better off using this technique. It's much easier and faster. The next example wants us to convert y equal negative x squared plus 8x minus 11 to vertex form and state the direction of the opening, the vertex. The function is either maximum or minimum, and the minimum or maximum value. To do this one, first of all, your a value is negative 1, so we factor negative 1 out, so we get x squared minus 8x minus 11. We just get the factor a from the terms that have x. Now, divide negative 8 by 2, we get negative 4, square it, we get 16, so add and subtract 16. So we get x squared minus 8x plus 16, always the plus first, minus 16 minus 11. Now these three terms is equal to x minus 4 squared, because x minus 4 squared is x squared plus 16 minus 8x, which is the same as this one, and then minus 16 minus 11. Now I'm going to distribute negative inside. I get negative x minus 4 squared plus 16 minus 11, which is negative x minus 4 squared plus 5. Now, looking at this equation, we know that a is negative number. So this means parabola opens downward. So we know the vertex is maximum. Now the question is that what is the maximum value? Because the coordinate of the vertex is 4 and 5. So we say the maximum is equal to 5. Now, to show you the fast way of doing it, I'm going to find the x-coordinate of the vertex just to show you how easy it is. So v sub x is minus b over 2a, which is minus b is minus 8 over 2a. A is negative 1, so it's negative 2, and this one gives us 4, which is the same as the x-coordinate of the vertex we found previously. To find the y-coordinate, we just sub 4 back in this equation, and we can find the y-coordinate of the vertex. The last example wants us to find the vertex form of y equal negative 3x squared minus 12x minus 9. So again, we are going to factor negative 3 out. So we get x squared plus 4x and then minus 9. Now, plus 4 divided by 2 is 2. Exponent 2 is 4. Add and subtract 4. So we get x squared plus 4x plus 4 minus 4 minus 9. Now, these three terms, I can write it as x plus 2 squared, because x plus 2 squared is x squared plus 4x, which is the same as this one, minus 4 minus 9. Distribute negative 3 inside, we get negative 3x plus 2 squared plus 12 minus 9, which is going to be negative 3x plus 2 squared plus 5. So this means the vertex is going to be at negative 2 and 5. Remember, the formula is x minus h. If this one is plus 2, this means that h has to be negative 2. Now, since a is negative, again the parabola opens downward. The vertex is at negative 2 and 5. This is the maximum, and the maximum value is 5. Again, if you want to do the shortcut, we can say that Vx is minus b. So minus 12 is 12 divided by 2a, which is going to be 2 times negative 3, which is 12 divided by negative 6, which is negative 2. And if you look here, we got the same answer much faster. And to find the y coordinate, we just put it back in this equation, and we can find the y coordinate.